So next we're going to move into automated endpoint detection and response testing. This environment has a lot of tools in place. We try to show you a little bit of variety. What we're using here is some Atomic Red Team, some Red Canary, CIS baselines on protected versus unprotected sites, Jenkins for automation. You get the general idea. Instead of using Splunk in this case, we're using Elastic, or ELK as it's often referred to. And then we have a few other things like Swift on Securities template for Sysmon and WASA, as well as MITRE Caldera. What we're going to show you from an EDR perspective is how to validate your endpoint detection response consistently. It's pretty common from a security perspective to buy a tool based on hype or industry reports, but inevitably you have to ask yourself, did I test it? Do I know it works? And if I did test it, what does or does not work? So that you understand the true business value of your investment. And more than anything, you're not finding out that it didn't work from your users or winding up on the news somewhere. So we're using the Red Canary 2020 threat report, taking the top 5. Trevor is going to demonstrate process injections, scheduled tasks, effectively living off the land attacks that are very common. And one, how to execute them manually, how to execute them in an automated fashion, and consistently and repeatedly test your EDR platform so that you know security is working as expected. So you're testing your tools, you're testing your sensors, and you're testing your response. All right, Trevor.
All right, thanks, Anthony. So that's a great question. We go down the path of how do we validate our tools. So today we're going to take a look at an approach for validating endpoint security tools, configurations, and event logging capabilities. Anthony mentioned there are many tools in the lab. They all have their own function to assist with making sure our security stack is configured properly, and our event logging doesn't leave us wanting more data after an incident has occurred. Questions we ask ourselves: how can we validate our level of preparedness? How can we identify any blind spots? And how can we test our security stack? One approach would be to simulate adversary behavior. How could we do that in a safe, controlled manner? How would you know what techniques are the most prevalent? So today we're going to demonstrate the use of Atomic Red Team, an open source adversarial emulation project based off the MITRE ATT&CK framework. The MITRE ATT&CK framework is a knowledge base of adversary tactics, techniques, and procedures based on real-world observations. The number of techniques are a bit overwhelming at first glance, but they're organized to make it easy to digest. Atomic Red Team can execute over 500 tests covering over 150 attack techniques, ranging from initial access and defense evasion to lateral movement and credential access. So as a starting point, we took a look at the Red Canary 2020 threat detection report. We reviewed the telemetry that they reported and collected from over 200 billion pieces of data, 6 million investigative leads, and 15,000 detection reports. We'll use this data to select the top 5 techniques and demo those today. So the goal of this demo is to determine if we're protected, determine if we could detect the technique, and make sure we're collecting all the right endpoint data if needed for incident response. So let's take a look here at the lab. I just have a quick, I'm out at the mitre.org website just to show the MITRE ATT&CK framework here, where we can take the techniques and we can find different types of execution or command and script interpreter. And PowerShell, for instance, we're going to demonstrate PowerShell today. So just going through here, we can see the procedure examples. These are any APT groups that might be using these in their malicious activity. But what we want to focus on here is mitigation techniques. Right, PowerShell, you can use antivirus or code signing or disablement, but also the detection. So if you look at every one of the items that we're showing today and you reference the attack website, you can find ways to detect this type of malicious behavior in your own environment. So that being said, let's take a look here. We have a Windows 10 VM that we have spun up here with a default configuration. I'll be using PowerShell to invoke the Atomic Red Team modules. The setup for Atomic Red Team is pretty straightforward. You just clone the Atomic Red Team GitHub repo locally, import the PowerShell modules, and then choose which MITRE ATT&CK technique you'd like to run. The tests that are executed are benign. They generally launch calculator, notepad, or command prompt instead of a malicious payload, but they're still effective in demonstrating the attack technique without causing harm to your test system. It's worth noting that the attacks are customizable by modifying the YAML file that's included. So the top technique here was process injection. It's the most prevalent technique found in the threat detection report. It's top of the list due to its usage by the TrickBot malware to execute arbitrary code for defense evasion and privilege escalation. Malicious code is injected into a legitimate process to make it harder to detect or run with elevated privileges. So we'll take a look here at the tests. First one here is PowerShell. So what I want to show is it's T1055 that we're going to use PowerShell for process injection. If we want to look here, we can use the show details command at the end, and it's going to show us what will run when we execute this. And it's the Windows 10 utility to inject DLLs. And we see the actual command here that it'll be using mav inject to inject the malicious DLL. One of the other items here is when you execute a test, you want to make sure you have all the prerequisites in order. So we can just go through here and we can take a look at the prereqs for that test. And we get a response back here that shows that the requirement is to have mav inject on your system. Since it's Windows 10 and it's built in by default, we do meet the prerequisite check. And then finally, we'll get on to actually executing the test. All right, so there we go. We have a notepad process running, and we see that the malicious DLL has been injected, and we see that with this pop-up dialog box. To confirm that, we can go through and we can check Process Explorer. We can come down and find the notepad process, and then we can take a look at the DLLs that were loaded, and we do see the 1055 DLL. So that's the first test that we'll be going through. Let's see. All right. Second test that we're going through is actually scheduled tasks. Scheduled tasks can allow an attacker to perform actions at startup or at a specific time. This allows the attacker to maintain persistence in your system. If a process is closed or the system's rebooted, then the malicious process can be relaunched via scheduled task. Establishing a baseline for automating and detecting of scheduled tasks on your endpoints is a great way to identify this behavior. Let's close out of that and get on to the scheduled task. One of the other arguments I want to show is the show details brief. What you can do is you can take a test and you can identify the test via its MITRE code and then look at the details brief, and it's going to show you all of the different tests that are associated with that type of scheduled task test here. So we're going to pick the second item. And how we can do that is just using the arguments test numbers 2. And what we see here is that the malicious task has been successfully created. So we'll take a look here at the scheduled tasks. I'll just do a refresh here, and we'll see that that task is shown up here. All right. The last bit here is I want to show that the atomic tests can actually clean up after themselves. So if we just copy and use the cleanup parameter, we can execute that. Come take a look at the scheduled tasks again, do a refresh, and you see that the scheduled task has been deleted. So we'll close out of that for right now. The third test we're going to jump into here is remote services, SMB Windows admin shares. So remote admin shares are used for lateral movement and malware propagation. Windows admin shares should be monitored and tuned to eliminate some false positives. So we'll take a look here at this test. All right, so we see basically we were able to map an admin share out to our domain controller. So that takes us on to the fourth item. The fourth most prevalent was PowerShell. PowerShell is used for a number of reasons: execution, remote code download, discovery purposes. It's on every Windows workstation and used heavily by administrators. A majority of macro-enabled malicious documents also leverage PowerShell to download and execute its payload. And it's best to limit PowerShell to admins or ensure that you're logging all PowerShell commands to your SIM. Here we'll go through a test of PowerShell. And we'll see here, I wanted to demonstrate a test that's actually blocked. You see that PowerShell is trying to download Mimikatz from the internet here, and Windows Defender had picked up that and blocked the threat. So that's a positive test. Many of the tests will fail, but that helps you focus on the ones that actually get through here. So we'll focus on test 14 here, where we're calling remote PowerShell. And you can see that we established a connection to our domain controller right here. All right. So the next item here is we have connectivity here for remote file copy or ingress file transfer. Remote file copy is the last technique we're going to show today. It's commonly used to deploy command and control executables to endpoints. Here we can see where bitsadmin.exe, a file transfer utility built into Windows, is used to download a file from the internet. Abusing bitsadmin.exe to download a remote file could be useful if PowerShell was blocked in your environment. So we'll take a look at the test for 1105. And we see here that we're starting a download completed, and we can take a look at that directory. And we see that the file was downloaded. So that concludes the testing piece. So let's take a look at automation. Since we've identified all the tests we wanted to complete, we can leverage the Atomic Red Team remoting capabilities to wrap these commands into a Jenkins job and be able to continuously integrate testing into our pipelines. So let's see here. So we have a Jenkins job. If you're not familiar with Jenkins, Jenkins is a free and open source automation server. So we used it to build this automation adversary emulation. If we take a look at the configuration behind it, we can see that we have a computer at it, we have a password, and we have a username that we're going to use. And then what we can do is take a look here. I have that actually set up as a scheduled task, but we can just take a look at one of the previous builds. And we can see that the same tests were all executed in sequence and that we had a success at the end. All right, and next we're going to move on to detection. So for detection, we're using Elastic, as Anthony had mentioned. Elastic's an open source search and analytics solution, commonly used as a tactical SIM. It's good to review the event logs that were created during our testing. We could take this information and create custom alerts, playbooks, automation workflows based on the details found within the event logs. For example, maybe we want to automate that remote file copy. Let's automate the URL lookup to determine if the website is known to be malicious, or check the hash of the DLL to do the same. If known malicious, we can prioritize the investigation and response. It is worth noting that out of the box, the level of detail that is included in Windows requires additional configuration to get this event logging that we have here today. In the lab environment, we're running Sysmon with the Swift on security configuration. That's going to be able to show us all the parent processes, command line arguments, process details, and the logs are written to the Windows event log and then forwarded to Elastic with WinLog beats. So take a look here at our Elastic instance. And we'll take a look here to see if we can spot process injection in some of our logs. All right, so here we are, we're doing a query. And we see that we have a process create. We see that mav inject was used. We see mav inject was called. This is the DLL. This is the working directory. And here is the PowerShell command that was actually run to execute. So all of this detail would be interesting in an incident response scenario, but we now have this detail that we can use to automate as well if we do some lookups. Take a look here at the scheduled tasks just to see what kind of data we collected there as well. All right, so here again, we have the process name. We have the creator process as command.exe. If we look through the other logs, we see we called scheduled task. We have the task name. We have the process that was going to execute, and at 8:10 p.m. Going down, we can see the same command line that is used to create that scheduled task. All right, and last, we'll take a look at the bits admin abuse to download files from the internet. All right, and here you see, again, we have a process creation command called bits admin for a transfer. We have the URL of what could be a malicious payload. We have the parent processes that we're calling that. What's also interesting is maybe we want to see who else downloaded that or made that DNS request. So we can go out and query to see what DNS requests were made to that GitHub user content as well. And we see that service host here was making that request. So the identification and testing process is important to building a mature security program and ensuring you are getting the most return on your security investment by validating your configurations. We talked about the top 5 most common attack techniques so that you can validate that you're collecting enough data related to these types of attacks. The tests we performed what would be considered living off the land, techniques that use built-in tools that already exist in a Windows environment and are trusted by the operating system. And it's relatively easy for an attacker to change hash values or IP addresses or domain names, but it's extremely difficult to change the tactics, techniques, and procedures, which is where we spend our time testing today.